Students, today we are going to study alternating current. Alternating current. What is alternating current? See, the electric current whose magnitude changes with time and direction reverses periodically is known as alternating current. The electric mains supply sends current in a circuit. This current may be represented by sine or cos function of time. To plot this alternating current, we draw sinusoidal graph or sinusoidal curve. If you see the graph, current is taken in y-axis and time on x-axis. And if we plot a sinusoidal graph, a sine graph, using the graph, we know that this distance is amplitude. The maximum displacement covered by the vibrating body. And here you see the maximum displacement covered by the vibrating body is represented by I naught. Let I be the value of current, or you can say instantaneous current at time t. Then we can calculate the value of that current. See, the instantaneous value of alternating current is I is equal to I naught sine omega t. Let the equation be equation number 1, or I is equal to I naught cos omega t. Let it be equation number 2. Suppose I is instantaneous current at time t. So we can write the equation I is equal to I naught sine omega t, where I naught is amplitude, maximum displacement. In other words, we can say I naught is peak value of current, or I naught is current amplitude. Now it is peak value of current, alternating current, and using sine function of time or cos function of time, we get same result. Okay, and if we take cos function of time, in that case we get this type of graph in case of cos function of time. So it doesn't matter whether you take I is equal to I naught sine omega t or I is equal to I naught cos omega t. Students, we know very well omega is equal to 2 pi upon t. 2 pi into reciprocal of time. And we know that reciprocal of time is frequency. That's why for omega we can write 2 pi f or 2 pi omega t. Okay. Now, similarly, the EMF or voltage whose magnitude changes with time and direction reverses periodically is known as alternating EMF. So, we can write instantaneous value of alternating EMF, that will be E is equal to E naught sine omega t or E naught cos omega t, where E naught is peak, maximum value of EMF. Okay, maximum value of EMF. So it is now, see, in case of alternating current, we can calculate peak value of current. Similarly, peak value of alternating EMF. Now, we will define average value and RMS value of current as well as EMF. See, mean or average value of AC. It is the steady current which, when passed through a circuit for half the time period of the AC, sends the same amount of charges as it done by the AC in the same time through the same circuit. We know I, instantaneous current, is equal to I naught sine omega t. Suppose the current flowing through the circuit remains constant for small time dt. The small amount of charge dq will pass through the circuit for time dt. Since charge q is equal to it, so for that small interval of time, we can write dq is equal to I dt. Substituting the value of I from this relation, we get dq is equal to I naught sine omega t. This dq will pass through the circuit in half time period. So, integrating this dq with limits t t 0 to time t by 2. Integrating this dq, we get q. Now, integrating whole quantity with limits 0 to t by 2, we can write in this way I naught sine omega t dt. Okay, now integration of sine omega t will be minus of cos omega t upon omega. So it will be I naught minus cos omega t upon omega. Now limits 0 to t by 2. Okay. Now for this, we can write I naught omega cos omega t 0 to t by 2. Since omega is 2 pi by t, substituting the value of omega, we get minus I naught upon 2 pi by t, then cos 2 pi upon t into t by 2 minus cos of 2 pi by t into 0, or q is equal to minus of I naught t 2 pi under bracket cos pi minus cos 0. We know that value of cos pi is minus 1, value of cos 0 is 1. So we get q is equal to minus of I naught t upon 2 pi into minus 1 minus 1. Students, see, after integration we get q is equal to minus of I naught t upon 2 pi into minus of 1 minus of 1. It will be q is equal to minus of I naught t upon 2 pi into minus 2. 2 will cancel out. Minus minus will become plus. So we get q is equal to I naught t upon pi. Let it be equation number 1. From the definition of average value of alternating current, we can write q is equal to I m t upon 2. Equation number 2. From equations 1 and 2, we get T upon 2 is equal to I naught T upon pi. From after simplification, we get Im is equal to 2 I naught upon pi. Substituting the value of pi, that is 3.14, we get Im is equal to 0.3636 I naught. It is Im, average value of alternating current, is equal to 0.636 peak value of alternating current. It is a relation between mean value or average value of alternating current and peak value of alternating current. Similarly, for alternating EMF, we write EM is equal to 0.636 E naught. For half of the cycle, we have got average value of alternating current. Im is equal to 0.636 I naught, where I naught is peak value of current. Similarly, for alternating EMF, E average or E mean is equal to 0.636 E naught. Now, during next half cycle, for one half cycle, we have calculated. For next half cycle, the mean value of AC will be equal in magnitude but opposite in direction. That's why if we get one value of Im positive, for next half of the cycle, it will be negative. Magnitude will be same but in opposite direction. That's why we will get with negative sign. For this reason, the average value of AC over a complete cycle is always 0. Now, students, we will calculate root mean square RMS or virtual or effective value of AC. See, it is that steady current which, when passed through a resistance for a given time, will produce the same amount of heat as the AC does, alternating current does, in the same resistance and in the same time. This RMS value of current is represented by I RMS or I effective or I V virtual, because it is called RMS value or virtual value or effective value of alternating current. Now, we are going to derive a relationship between IRMS and peak value, I naught, peak value of alternating current. Since I is equal to I naught sine omega t, where I is instantaneous current, I naught peak value of alternating current, sine omega t, where omega is 2 pi upon t. Suppose constant current passes for a small time dt, the small amount of heat energy dH will produce in the resistance R in time dt. So, using Joule's heating effect, we can write dH for small amount of heat energy, dH is equal to I square R dt, or Now you see dH is equal to I square R dt. Small amount of heat energy for smaller interval of time. So substituting the value of I, we get dH is equal to I naught sine omega t whole square RT. Now to get total net value of heat energy, we integrate this relation with limits time t is equal to 0 and t is equal to t by 2, half of the time. So integrating this relation, we get h I naught sine omega t square whole square r dt, integrating between with limits 0 to t by 2. Here you see I square I naught square r being constant, we can take out of the integration sign. So we can write I naught square r integration with limit 0 to t by 2 sine square omega t dt. After integration we get h is equal to I naught whole square r upon 2 into t upon 2 minus 0, or heat energy. Here we are getting h is equal to I naught square r upon 2 into t upon 2. After integration, we get h is equal to I naught square r upon t into t upon 2. Let it be equation number 1, where h heating effect, I naught peak value of alternating current, r resistance of the metallic conductor, t time period. See, if I RMS is RMS value of AC, then by definition we can write H is equal to I RMS whole square R into T upon 2. Let it be equation number 2. From equations 1 and 2, we get I square root mean square RMS value of I R into T upon 2 is equal to this much. From here we get the value, and comparing these two values we get I RMS is equal to I naught upon root 2. Substituting the value of root 2, we get I RMS is equal to 0.707 times I naught. It is a relation. This equation is a relation between RMS value of alternating current and peak value of alternating current. We are having a relation between them, that is I RMS is equal to 0.707 I naught. Similarly, for alternating EMF, E RMS will be equal to 0.707 E naught. The RMS value of AC is same even for a complete cycle of AC. This fact is made use of to construct hot wire instrument. Okay, this fact is made use of to construct hot wire instrument for measuring currents and voltage. This fact is made use of to construct hot wire instrument for measuring currents and voltage. AC ammeters are used to measure RMS value of current, alternating current. Thank you.